This is the assignment, so hopefully you are on the right page and watching the correct video. Let's go ahead and get started. Number one, they want you to find the 6 trig functions or values for this angle right here. I know it's a little blurry. If you'll look here, my other problems do get less blurrier, okay? So just kind of put up with this one. But what I do is I go straight across and I label this my opposite side. Here's my right angle, so I straight across call this my hypotenuse. I'm going to start using O's, H's, and A's. So I'm going to put O for opposite, H for hypotenuse, and A for adjacent, okay? And that's kind of a weird looking symbol, but that's okay. It's one of those Greek letters I warned you about. So sine, cosine, tangent, cosecant, secant, and cotangent. All right, and here we go. We'll go through this pretty quickly. Sine is opposite over hypotenuse, so 15 over 17. Cosine would be adjacent over hypotenuse, 8 over 17. And tangent is opposite over adjacent, 15 over 8. Now, cosecant is the inverse of sine, so that would be 17/15. Secant is the inverse of cosine, so 17 over 8. And cotangent is the inverse of tangent, so I would put 8/15. All right, moving on to the next problem. If I go too fast, just pause the video. Okay, here's the angle we're dealing with, so I'm going to draw a line going across. This is my opposite side. Here's my right angle. This is my hypotenuse, and this would be my adjacent side. With that in mind, let's go ahead and list out my functions. Sine, cosine, tangent, cosecant, secant, cotangent. And I'm going to quickly copy this so I don't have to keep doing this every time. It'd be a lot easier. Okay, now here we go. All right, the sine of angle B, or I guess it's beta, it's the Greek letter B, but the sine of B would be opposite over hypotenuse. That's 0.3 over 0.5. Now students, we never want a decimal within a fraction. You're allowed to move the decimal up top as many places as you want, as long as you move the bottom the same amount. So I'm going to move the decimal one place, move the decimal one place. 0.3 over 0.5 is simply 3/5, okay? Cosine of B, that's adjacent over hypotenuse. That would be 0.4 over 0.5. Move each decimal one place. And you say, well, Mr. Earhart, I didn't know that this was not an acceptable answer. I understand. And that's a perfect example of why you should do your homework and why you should check your answers, okay? You do not want a decimal within a fraction. That's just unorthodox. So we move the decimal one place. But if you move it one place here, you must move it one place here, and so there we go. Tangent of B is opposite over adjacent, so it would be 0.3 over 0.4. And of course, moved both decimals one place, and you would get 3/4. And now, the cosecant is the inverse of sine, so the answer would be 5/3. Secant is the inverse of cosine, so secant would be 5/4. And then cotangent is the inverse of tangent, so cotangent would be 4/3. And now we're ready to move on. Not too bad. Okay, problem number 3. This is the angle we're dealing with. So I'm going to go straight across over here and call this my opposite side. Here's my right angle. I'm going to go straight across and call this my hypotenuse side. And the only side left is 3. That's my adjacent side. Okay? Now, I know that this is an alpha symbol, but I'm trying to save time. I think you guys can respect that. So when I do this right here, I know this B should be an A or an alpha, and please feel free to do that. Please feel free to go ahead and do that in your notes. I'm not going to take time and do that because that's really not superbly important, okay? All right, the sine of this angle that we're dealing with then would be opposite over hypotenuse, so 3 square root of 3 over 6. The cosine is adjacent over hypotenuse. That would be 3/6, which would be 1/2. And by the way, students, I forgot, do you see this right here? Please do not ever reduce a fraction with a number under the radical, with a number outside the radical. But you see how this 3 and 6 are both not under the radical? See how this 3 is under the radical? Here's your radical right here, that box. And see how 3 is on the inside? You should be able to see that. Well, you don't want to reduce an outside number with an inside number, but you can. In fact, you have to. You have to reduce outside numbers. So what goes into 3 and 6? Well, 3 does. So this would be a 1 and this would be a 2. So really you have 1 square root of 3 all over 2. And you do not need to put that 1 if you don't want to. You can, but you don't have to. Okay, continuing on, tangent would be opposite over adjacent. So 3 square root of 3 over 3. Opposite over adjacent. And notice, of course, your 3's here would cancel. And so you're simply left with square root of 3 over 1 or just square root of 3. All right. Now, cosecant is the inverse of sine, so cosecant would be 2 over square root of 3. Now I know we've got to change that later because we have a radical in the denominator, but let's worry about that later. Secant is the inverse of cosine. Cosine is 1/2, so secant would be 2 over 1. If you want to put just 2, that's totally acceptable. Cotangent is the inverse of tangent, so you have square root of 3. Now that's really over 1, square root of 3 over 1. So if you were to flip that, you would get 1 over square root of 3. Now, 2 of my answers are unacceptable, this one and this one, okay? This answer is awesome, this one's great, this one's sweet, this is good, these two are not. So let's work on these two. Remember what to do. You don't want the square root of 3 here, so you take this fraction and you multiply the top and the bottom by the square root of 3. 2 times the square root of 3 is 2 square root of 3. And square root of 3 times square root of 3 is just 3. There, that's acceptable. Okay, I don't want this square root of 3 in the denominator, this radical in the denominator, so I'm going to multiply the top and the bottom by the square root of 3. 1 times the square root of 3 is just square root of 3. And square root of 3 times square root of 3 is 3. Now here's where a lot of students, even this problem here, they want to reduce these 3's. Or here, they want to reduce these 3's. No, no, no. Remember what I said up here. This is an inside number. It's under the radical. This is an outside number. It's not under a radical like this. It's not. So you cannot reduce those two numbers. So that is totally acceptable. Now, if there was a 9 right here, then you could reduce the 9 to 3. But there's not, and there's nothing you can do. Okay? I hope that we're getting this. Okay, let's continue on to the next page. Let me grab a quick, or to the next problem, get a drink of water here. All right, problem number 4. Here's the angle we're dealing with, right here. So we go straight across. This is my opposite side. There's your right angle, so this is my hypotenuse, and this would be your adjacent side, okay? And here we go. I know that my angle is different. It should be theta right here, but I'm not going to change that. Okay, sine of theta would be opposite over hypotenuse. Now watch. That's 6 over 13 over 2. Now your calculator should simplify that. You students that had me last year, remember you type in 6. Now listen to me. If you have a graphing calculator, Corey, I don't know what you have. Caleb, I don't think you had a graphing calculator, so you two hold on a second. Chase, Matthew, you type in 6 divided by, then you use parentheses, 13 divided by 2. You hit enter, you get out some decimal, and then you hit the math button on the left side of your column, the left side of your calculator. You hit math, enter, enter, math, enter, enter, and you will get a fraction. Now for you guys, Caleb and Corey, you need to call me, email me, or figure this out. But 6 divided by 13 over 2 is, you should get out 12 thirteenths. 12 thirteenths, okay? That's what you should be getting out. So we don't want, well, Mr. Garrett, what's wrong with this answer? You don't want a decimal within a fraction. You don't want a fraction within a fraction. That's totally unorthodox and not simplified, okay? So 6 divided by 13 over 2 is 12 thirteenths, okay? Your calculator should do that for you. If you want to see a quick example down here, 6 divided by 13 over 2, well, that's the same thing as 6 over 1 times 2 thirteenths. Remember, you multiply and flip the second fraction, and you would get out 12 thirteenths. So if you don't want to use a calculator, you want to do it longhand, that's totally fine. All right, cosine of b. adjacent over hypotenuse. And by the way, if you're struggling with some of this, that's why you A, have my phone number and email, and B, that's why you come over on Mondays to know exactly where you're struggling and ask questions, okay? That's why we do that. Okay, I've written kind of small here, but it's adjacent over hypotenuse, 5 over 2 over 13 over 2. And if you type that into your calculator, it'd be 5 over 2 times 2 over 13. I'm getting 10 over 26, which would reduce, excuse me, to 5/13. So your answer here should be 5/13. All right, tangent is opposite over adjacent, so 6 over 5/2. And if you simplify 6 over 5/2, you should get 12/5. 12/5. Okay? All right, now these should be easier because we just have inverses. So the answer to cosecant is the inverse of sine. So the answer here would be 13 over 12. Secant is the inverse of cosine. So we would have 13 over 5 for an answer. And cotangent is the inverse of tangent. So my answer here would be 5/12. I hope this is making sense. Moving on. All right, number 5. You know, I don't have my book in front of me. I think what they want you to find here, let me see. Hold on one second. Okay, I'm back, students. I wasn't sure what the directions said, but I see now that numbers 5 and 6 are just like numbers 1 through 4. They want you to list out all of the trig functions again. So I'm going to make this a little bigger so we can see it easier. There we go. And here we go. Here's your angle. I'm going to use a different color so we can see it better. There's my angle. So I go straight across. This is my opposite side. Here's my right angle. So I go over here. This is my hypotenuse. And this is my adjacent. Now, do you see the problem? We're missing one side. We do not know the length of the hypotenuse. So remember Pythagorean's theorem. A squared plus b squared equals c squared. So you take one leg, square it. You take the other leg, square it, add them together, and that equals the hypotenuse squared. Okay? We have to know all three sides, students, before we can find the 6 trig functions. So I would have 49 plus 16 equals 8 squared. And then I would have 65 equals 8 squared. All right? And there we go. Now, I've got to take the square root of both sides to get h by itself. So the square root of 65 is just the square root of 65. And the square root of 8 squared is h. So I come up here and I write square root of 65. I know that's hard to see, but you've got a book you can look at there, so you should be fine. Now, here's again, my functions I'm going to use. So there they are. And let's see how we do. All right. Sine is opposite over hypotenuse. So I would have 7 over square root of 65. I know that's not acceptable. We'll worry about that later. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent, 7 over 4. Now, cosecant is the inverse, so we would have square root of 65 over 7. Secant is the inverse of cosine, so square root of 65 over 4. And cotangent is the inverse of tangent, so the square root, or excuse me, 4 over 7. There we go. Now, you understand these two answers are unacceptable. 1, 2. Hopefully you understand that, okay? Those two answers are not acceptable. So, with that in mind, I'm going to have to change those answers. So, I'm going to do this one. I'll do it in red here, I guess. I don't want this radical in the denominator, so I'm going to multiply the top and the bottom by square root of 65. Square root of 65. All right? Let's see if green shows up a little better. So, when I do that, 7 times the square root of 65 is 7 square root of 65 all over. Square root of 65 times square root of 65 is 65. There you go. Now, same thing here. I'm going to multiply the top and the bottom by the square root of 65 over square root of 65. And if I do that correctly, 4 times the square root of 65 is 4 square root of 65. And square root of 65 times square root of 65 is 65. Can you reduce 7 and 65? No, you can't reduce. There's no number that goes into them. And there's no number that goes into 4 and 65 evenly. So there are your two answers. I hope that helps. Let's take a look at number 6. Now, notice we're missing one of our sides again, but I'm going to go ahead and stick to basics. First of all, I circle this. I go straight across over here. This is my opposite side. This is my hypotenuse side, and this is my adjacent side. Now, notice we're missing one of the legs. Remember, the two sides that are not the hypotenuse are your legs. So this is a leg, and this is a leg. Do you see how we're missing one of the legs? In the last problem, we were missing the hypotenuse. So we had to do this to find the hypotenuse. Now we're missing a leg. So we're going to have to use Pythagorean's theorem to find the leg. So I have one of my legs, which is 8.2 squared. My other leg, I don't know, I'm going to call it x, I guess. I don't know my other leg. And I know the hypotenuse is 9. Make sure you know where all those numbers came from. All right. Now I'm going to grab my calculator real quick. And 8.2 squared would be 67.24. So this would be 67.24 plus x squared equals 81. And now I'm going to subtract 67.24 from both sides. If I do that correctly, I will get x squared equals negative. Excuse me, not negative, I apologize, positive 12.76. And now I'm going to take the square root of both sides. Now, let me very quickly, hold on one second. Okay, I typed in the square root of x squared is x, the square root of this decimal here. You know, in the past, I've said, hey guys, keep it a square root. And that's fine, but in this case here, because I have a decimal, that's really weird to have the square root of a decimal. Like in the last problem we did, let me go back a page. We had the square root of 65 right here. Okay, that's fine, we'll leave it square root. But in this problem here, the square root of 12.76, I am just going to make that a decimal. And so I'm going to round 3.57. 3.57. Okay? So this side here is 3.57. All right? So with that in mind, I mean, we are ready now to go ahead and find our 6 trig functions. So let's go ahead and get started. Here we go. Sine is opposite over hypotenuse, so 3.57 over 9. Now remember, we don't want a decimal within a fraction, so I'm going to move this decimal 2 places. That would give me 357, but I must move the decimal 2 places down here. That would give me 900. I am not going to worry about reducing that. No way. I already rounded the decimal down here. That is totally sufficient. In a fraction that big on a test or a quiz, you could just leave that alone. I have no problem with that. Cosine is adjacent over hypotenuse. And of course, we don't want a decimal within a fraction, so we move the decimal 1 place. That gives us 82. Move the decimal 1 place down here. That gives us 90. Okay, tangent is opposite over adjacent, so 3.57 over 8.2. Move the decimal 2 places. That's 357. Move the decimal 2 places. 820. Mr. Earhart, I only got to move it 1 place. Well, you got to move it the same amount of places. If you moved it 2 places up top, you got to move it 2 places in the bottom, okay? You got to be consistent. And now the rest falls into place pretty nicely because we know we have inverses. So cosecant of b, the inverse would be 900 over 357. The secant of b would be an inverse of cosine, so 90 over 82. And I know that's reducible. I'm not going to worry about it. The cotangent is the inverse of tangent, so 820 over 357. Very cool. Moving on. All right. This one here should be pretty simple. They want us to find cosecant, secant, and cotangent. All right. Well, I'm sorry, I used x. I apologize. It should be alpha, I think is that name. I'm not really for sure about that. Okay, very good. Cosecant is the inverse of sine, so we would have 3 over square root of 5. Secant is the inverse of cosine, so 3 over 2. And cotangent is the inverse of tangent, so I would have 2 over square root of 5. Now, two of these answers are not acceptable because of the radical in the denominator. So if I multiply the top and the bottom by the square root of 5, I would get 3 square root of 5 over 5. And here, if I multiply the top and the bottom by the square root of 5, I would get 2 square root of 5 over 5. There we go. Pretty simple. Moving on. All right, same thing here again. We're looking for the cosecant of, I think it's beta, and the secant of beta, and then cotangent. All right. Here we go. Well, cosecant is the inverse, now watch carefully, is the inverse of sine, so I would have 3 over 2 square root of 2. Secant is the inverse of cosine, so I would have 3 over 1, or just 3 if you like. Cotangent of b is the inverse of tangent, so it's 2 square root of 2. Really, it's over 1, so if you flip that, you get 1 over 2 square root of 2. Now, be careful on these. Watch carefully. This is an unacceptable answer right here. So watch what I do. Be careful, be careful, be careful. 3, 2 square root of 2. Now watch. Times square root of 2 over square root of 2 equals. Well, 3 times square root of 2. We know that's easy. 3 square root of 2. Now be careful. Watch this. Square root of 2 times square root of 2 is just what? 2. But what's on the outside right here you can't forget about? Another 2. Let's go over that again. Watch this carefully. Square root of 2 times, if I didn't have this 2 right here, then square root of 2 times square root of 2 would just be 2. But unfortunately, I do have a 2 right here on the outside. So square root of 2 times square root of 2 is 2. And then bring over this 2, which would be a 2. You do multiply those, so you get 4. So the answer is 3 square root of 2 over 4. Let's try that on this problem over here. 1 over 2 square root of 2 times square root of 2 over square root of 2. 1 times square root of 2 is square root of 2. Now be careful. Square root of 2 times square root of 2 would be just 2. And then bring this 2 over, multiply those, and you get square root of 2 over 4. Those are the correct answer for these two right here. All right. And now very quickly, 9 through 16. Hopefully these will go pretty quickly. I think these are difficult problems here, but we'll try to go as fast as possible. We have 8. I think I'm going to cut this back. In fact, I'm going to go ahead and tell you now, we're going to go ahead and make this, we're going to do numbers 9, 11, and 13. 9, 11, and 13. Okay, so here we go. First of all, notice I have one trig function, which is sine of theta is 24 over 25. I'm going to move that out of the way. So the first thing I want to do, students, is draw a right triangle. I don't care what it looks like. That's good enough like that. And let's go ahead and quickly label the sides that we do know. For example, sine means, well, first of all, let's name one of these angles theta. I'm going to call it this angle here. So this is my theta right here. And don't forget, sine is opposite over hypotenuse. So now I know my opposite side is 24, my hypotenuse is 25, and now using Pythagorean's theorem, notice I'm missing a leg right here. So I'm going to say one of my legs is 24, plus my other leg, I don't know, and my hypotenuse is 25. Okay, so using a calculator here, 24 squared is 576, and 25 squared would be 625. Now I'm going to subtract or move the 576 over and make it negative. And when I do that, I will get 49. So L squared equals 49. And now take the square root of both sides. The square root of L squared is L. The square root of 49 is 7. So now I know that my missing side is 7. So this will be pretty easily, actually. I don't think we'll have too much of a problem here. Let's go ahead and do this. I know it says B right there. I understand that. Just ignore that, please. And we're going to assume that it is theta. Slide that right up there. All right, and here we go. Not sure what just happened. All right, I apologize for wasting time here. Okay, well this will be good enough. All right, so let's go ahead and get started. We already know that sine is 24 over 25. And now we know all three sides of our triangle. So cosine. Let's see. This is your angle, right? So go straight across. This is your opposite side. This is your hypotenuse side, and this is your adjacent side. Cosine is adjacent over hypotenuse, so 7 over 25. Tangent is opposite over adjacent, so 24 over 7. Cosecant is the inverse of sine, so 25 over 24. Secant is the opposite of cosine, so 25 over 7. And cotangent is the inverse of tangent, so 7 over 24. Two problems left, and we're finally done. Number 11. All right, tangent of theta is 2. Now, please watch carefully how I do this. The first thing I'm going to do is I'm going to draw my right triangle. So there we go. Next, I'm going to fill it in. Now, they give us one trig function, and that's tangent. And we're going to call, this is whatever that angle is called. I don't know what we call that Greek symbol. I'm going to put it right up here. All right? There we go. So I go across. This is my opposite side. This is my hypotenuse side. This is my adjacent side. Yes, you could have put this down here if you wanted to, and you'll still get the right answer as long as you do it correctly. Now, don't forget, 2 is the same thing as, now watch carefully, 2 is the same thing as 2 over what? 1. And tangent is opposite over adjacent, right? Sure it is. So opposite then would be 2. Here's my opposite side. Adjacent would be 1. And now using Pythagorean's theorem, we're going to find this missing side. So I know two legs. One leg is 1. The other leg is 2. So 1 squared plus 2 squared equals my hypotenuse squared. So 1 times 1 is 1. 2 plus 2 times 2 is 4. 1 plus 4 is 5. Now take the square root of both sides. The square root of 5 is simply the square root of 5. And the square root of h squared is h. So now I know the length of the hypotenuse is the square root of 5. All right? So with that in mind, we're now going to go ahead and find our other 5 values. Now we know 1 already, okay? We know tangent equals 2. Now let's go, they give that to us right here. Now let's go ahead and find sine. Opposite over hypotenuse, so 2 over square root of 5. We'll have to change that later because we don't want a radical in the denominator. Okay, cosine of b. Adjacent over hypotenuse, that's 1 over square root of 5. Now, cosecant is the inverse of sine, so the answer for cosecant is square root of 5 over 2. Secant is the inverse of cosine, so we would have square root of 5 over 1, or just square root of 5 is acceptable. Cotangent is the inverse of tangent. Well, it's 2, which is really 2 over 1. And so if you flip 2 over 1, you get 1/2. There's my answers. And this answer here, you must multiply the top and the bottom by the square root of 5. So your final answer for sine would be 2 square root of 5 all over square root of 5 times square root of 5 is 5. And then down here, you must multiply this fraction by the square root of 5 over the square root of 5 because we do not want a radical in the denominator. 1 times square root of 5 is square root of 5. Square root of 5 times square root of 5 is just 5. So there, we did it. One more problem and we're finally done. Y'all have done pretty well. Number 13. Okay, cosecant. Now this is a little interesting, so I hope you'll take some good notes. Let me get a drink of water here. Last problem, so work hard, finish well, we're just about done. Go ahead and draw your right triangle like we always do. And then I really don't care if you know, what angle you call theta. I'm just going to go ahead and use the top angle like we've been doing. So I go across, this is my opposite side. I go across, this is my hypotenuse, and this side is my adjacent. Now the problem is we have a decimal. How is that going to help? Well, please let me teach you something. Please watch this, students. The cosecant of theta is the same thing as 1.5. Well, 1.5 is 1.5. Is it not? Sure it is. And 1.5 is the same thing as 3 over 2. Is it not? So really, instead of saying the cosecant of theta is 1.5, I'm going to say the cosecant of theta is 3 over 2. Now, why did I do that? Well, I did that because I really want a fraction. Because if I have a fraction instead of a decimal, now watch what I can do. Um, the formula for cosecant is hypotenuse over opposite. And now that I have a fraction, 3 over 2, now I know the hypotenuse is 3 and the opposite is 2. Look, students, if I had left 1.5, 1.5, there's no way I would have known these two sides right here. But if I convert 1.5 to 1.5, which is the same thing as 3 over 2, now I know 3 is my hypotenuse and 2 is my opposite side. So my hypotenuse is 3, my opposite side is 2, and now we're missing a leg. Remember, any side in a right triangle that's not the hypotenuse is a leg. So this is a leg, and this is a leg. So I'm missing one of the legs of my right triangle. So I'm going to simply say, I'm going to call it x. So one leg is x, x squared. The other leg is 2, 2 squared equals the hypotenuse squared, 3 squared. Well, x squared plus 4 equals 9. Subtract 4 from both sides. X squared equals 5. Take the square root of both sides. The square root of x squared is x, and the square root of 5 is square root of 5. So now I found my missing leg, square root of 5. You've got to know how to use Pythagorean's theorem. Now, I know that I'm not using the right letter here. I know it's supposed to be theta, but that's okay. So I know cosecant. I already have that one. It's 3 over 2. I got that from right up here. Okay, so we're good there. Now, here we go. Sine. Well, sine of b is opposite over hypotenuse. That would be 2 over 3. And cosine is adjacent over hypotenuse. That would be square root of 5 over 3. Tangent is opposite over adjacent. That would be 2 over square root of 5. Now, we're going to have to change that later. We already know what cosecant is. Secant is the inverse of cosine, so 3 over square root of 5. We'll have to change that later. And then cotangent is the inverse of tangent, so square root of 5 over 2. Now, let's circle the ones we need to change. We've got to change this one because there's a radical in the denominator, and we have to change this one. So 2 over square root of 5. We're going to multiply the top and the bottom by square root of 5, square root of 5. 2 times the square root of 5 is 2 square root of 5. Square root of 5 times square root of 5 is 5. Multiply the top and the bottom by square root of 5, square root of 5. 3 times the square root of 5 is 3 square root of 5. Square root of 5 times square root of 5 is 5. There we go. Wow. Pretty long homework assignment, but we got it done. And that is basically it. I hope this was a help to you.